Namaskar. We are going to deal with the topic silk bleaching now. Before we could know about the silk bleaching procedure, it is important to know about the characteristics of the silk fiber. As we look into the composition, the silk is chiefly composed of 80% of fibroin, which is protein in nature, and 20% of the gum, which is otherwise called as silk gum. As with this the strength, silk as a fiber has a good tensile strength which allows it to withstand great pulling pressure. Silk is the strongest natural fiber and has a moderate abrasion resistance. The strength of the thrown yarns is mainly due to the continuous length of the fiber. Spun silk yarn, though strong, is weak than the thrown silk of the silk filament yarns. Reaction to bleaches. Silk, like wool, is deteriorated with chlorine bleaches like sodium hypochlorite. However, mild bleach of hydrogen peroxide or sodium perborate may be used for the silk. Chemical processing of silk. Treatment with alkalis. Alkalis have severe destructive effect on proteins. Severity of the treatment required to remove sericin from the given sample depends on the type of the silk. Degumming with soaps in the presence of alkalis is in practice since a long time. Here soap acts as a degumming agent and the alkalis aid the process. Bleaching of silk. Natural coloring matters present in silk are associated mainly in sericin and hence are eliminated during degumming. The natural coloring matter of silk can be roughly divided into yellow, green and brown pigments. However, the residual pigments are absorbed by fibroin and hence silk fabrics made from the yellow raw silk or after degumming are not white but have a cream color. The bleaching process may be based on reducing agents or oxidizing agents, but material bleached with reducing agent tend to reoxidize and to original color may be restored. Hence, oxidizing bleaching is mostly preferred. Predominant reducing agents used are sulfur dioxide, sodium hydrosulfide and sodium or zinc sulfoxylate formaldehyde, while the oxidizing agents used are potassium permanganate, sodium perborate, sodium peroxidase and hydrogen peroxide. The hydrogen peroxide is the most preferred bleaching agent. The chlorine based bleaching agents are bleaching powder, sodium hypochlorite and sodium chloride, which are generally not used since these agents tend to chlorinate the fibroin. Natural coloring matter present in the silk are associated mainly with sericin and hence are eliminated during degumming. The natural coloring matter of silk can be roughly divided into yellow, green and brown pigments. However, the residual pigments are absorbed by fibroin and hence silk fabrics made from the yellow raw silk after degumming are not white but have cream color. Silk bleaching process may be based on reducing agents and oxidizing agents. The reducing agents process is called as reductive bleaching. Predominant reducing agents used are sulfur dioxide, sodium hydrosulfide and sodium or zinc sulfoxylate formaldehyde. The material bleached with reducing agents tend to reoxidize and the original color may be restored. Hence, oxidizing with bleaching agents mostly preferred. Oxidative bleaching. The oxidative agents are potassium permanganate, sodium perborate, sodium peroxide and hydrogen peroxidase. The hydrogen peroxide is the most preferred bleaching agent. A typical process or a recipe would include 2 to 4 hours of treatment at 70 degrees centigrade or 1 to 2 hours at 80 to 85 degrees centigrade with 10 to 15 ml per liter hydrogen peroxide, which is 35% of the solution, and 1 gram per liter ADTA, which is 30% of the solution, and 3 grams per liter sodium pyrophosphate to pH 9, followed by thorough rinsing. The chlorine based bleaching agents such as bleaching powder, sodium hydrochloride and sodium chloride are generally not used since these agents tend to chlorinate the fibroin. Bleaching of silk with hydrogen peroxidase. The natural color of the silk thread differs depending upon the type of the silk and its feeding habit. Although the bulk of the natural dyes stuff such as chlorophyll, xanthophyll and keratin are to be found in the silk gum, the digum mulberry silk has also strong yellowish inherent color. Since some of the sericin is tenaciously held by the fibroin, complete elimination of the color of the degumming is not achieved. Thus, the fabrics manufactured from yellow raw silk retain a yellowish tint after boiling off. This natural yellowish tint or silk is desired by some fashion designers as a soft white or natural shade. The desired degree of whiteness can be relatively or easily achieved with the Bombyx mori silk on bleaching. With Tussa silk, the yellowish coloring of the fibroin is considerably more intensive. One reason for is that the Tussa silk, the sericin also penetrates the actual silk fiber, so that the natural dye stuff tend the Tussa silk fibroin a typical brownish yellow to greenish yellow color. The natural coloring matter is the tannin of the oak tree leaves on which Tussa silk is fed. Bleaching process for Tussa silk to get white fabric is thus usually very difficult, which makes such silk unsuitable for white fabrics or for certain pastel tones. The silk may be bleached by oxidative as well as reductive methods. If a very high degree of whiteness is required, solution from both the methods in the form of double bleach is applied. The best method for bleaching the silk is the use of hydrogen peroxide in the separate bath. The perhydroxyl ion or even atomic oxygen is responsible for the oxidation effect of the organic coloring matter present in the silk and thus for bleaching effect. The recipe for bleaching two varieties of the silk with the hydrogen peroxide are given in the table here. The material for degumming is entered into a preparatory bleaching. Recipe for bleaching silk with hydrogen peroxide for mulberry silk and also for the wild silk. The chemicals used here are hydrogen peroxide 35% by weight, stabilizer, and with a material required ratio of 1:20 for mulberry silk and 1:30 for wild silk. The temperature maintained here for mulberry silk are 75 to 80 degrees centigrade, and for the wild silk it is 80 to 90 degrees centigrade. And the time of bleaching takes for about 1 to 2 hours for mulberry silk and 3 to 4 hours for Tussa silk. Hydrogen peroxide is required as 15 to 20 ml per liter for mulberry silk and 20 to 25 ml per liter for the wild silk. Stabilizer 2 grams per liter is used for mulberry silk and 4 grams per liter is used for wild silks. Recipe for bleaching the silk and hydrogen peroxide bath at 40 degrees with these fibers which are sensitive to alkali. The alkali necessary for activation of hydrogen peroxide must be added to the bleaching bath should be ammonia or tetrasodium pyrophosphate. The pH value of the bleaching liquids should lie between pH 8.5 to 9. Stabilizers are added to the bath to achieve slow separation of the oxygen needed for the bleaching effect. Water, glass, which is often used as a stabilizer, should not be used for bleaching silk because owing to the precipitation of salicylic acid and the silk can be hard, brittle to handle. In this case, tetrasodium pyrophosphate and fatty protein concentrations are the ideal choice. The mixture of sodium silicate and trisodium phosphate or organophosphate exert a great stabilizing effect on the peroxidase and help to control bleaching action. Generally, one should consider whether instead of seemingly contradictory method of using activators on the one hand and stabilizers on the other hand, it would be better to have exact metering of the hydrogen peroxide solution. The dispensing system that most dye houses are now using make this feasible. Hard water with metallic salts or impurities is avoided as the metal act as crystal and weaken the silk. It is advisable to use stainless steel or ammonium steel for the rods. Bleaching above the specified temperature lower the tensile strength of the silk and it becomes yellowish. The bath is gradually raised to required temperature in light hours and bleaching is done at this temperature for specified time. Whereas the bleaching of the mulberry silk is complete after about 2 hours. The time required for bleaching tussa silk can be a lot longer depending on the origin and inherent color. The silk after bleaching is thoroughly rinsed first with the warm water, then with the cold water, hydro extracted and dried. Standing baths of peroxides can be used by replenishing the bath with 1/3 of the quantity of the hydrogen peroxide and 1/4 of the quantity of the stabilizer originally taken for bleaching. Silk goods to be sold as white require a treatment of 0.8 to 0.5% optical whitening agent along with 0.5% of globus salt at 45 degrees centigrade for 20 minutes at pH 4 to 5 with an addition of acetic acid. Ultramarine blue is also recommended in the optical brightening bath to obtain a bluish tinge to white silk goods. Bleaching of silk with reducing agents. Silk fibroin is highly sensitive to oxidizing agents like hypochlorite and chloride solution. Oxidation and substitution in the benzene ring of tyrosine is responsible for degradation of the silk with the formation of chloroamino acids, ketonic acids and chloroamines in several stages. The next table, bleaching of silk with reducing agents. This is the procedure of using the reducing agents and the conditions meant for them. For sulfur dioxide or sulfurous acid, the conditions maintained are 4 to 6 hours at an atmosphere of SO2 yellowish tint obtained. Sodium hydrosulfide, where the reaction takes place as follows: Na2H2O4 plus 4H2O2 yielding 4NaHSO4 plus 3H2. The conditions maintained are 4 to 6 hours at temperature around 50 degrees and pH 7 concentration around 45 grams per liter. Solubilized hydrosulfide. It requires a condition of 30 to 90 minutes at temperature of 60 to 90 degrees centigrade, pH 5 to 7, concentration around 10 grams per liter. Sodium sulfoxylate NaHSO2 CH2O2 plus H2O2 yielding NaHSO3 plus H2. Concentrations being 4 to 6 grams per liter with a temperature of 60 to 90 degrees centigrade temperature with a pH of 4 to 5.5 and with a time of 20 to 30 minutes. Reduction bleaching of the silk is generally carried out with sodium hydrosulfide or appropriate stabilized commercial products on the basis. The silk fibroin is resistant to reducing agents since the bleaching effect is poorer than with the peroxide bleaches. The term half bleach is sometimes used. Sometimes silk is still bleached with sulfur dioxide in gas form. To do this, the dampened fabric is subjected to sulfur dioxide gas and several hours it is an enclosed chamber. Though the formation of sulfur dioxide and some dyestuffs are naturally destroyed, water soluble leucocompounds which then have to be washed out so as not to risk reoxidation and thus yellowish during storage. The frequently noticed unpleasant odor of the remaining sulfur dioxide on the fabric can be eliminated by rinsing with hydrogen peroxide of 35% strength. If a very high degree of whiteness is required, a double bleach process is recommended. Here, bleaching is carried out on two separate stages. First, the silk is treated 3 to 5 grams per liter stabilized sodium hydrosulfide at 60 degrees for 1 hour, followed by additive bleaching using H2O2 10 to 20 ml per hour, 35% strength and 2 to 3% sodium silicate, the pH of the bath being maintained at 8.5 to 9 at 90% degree centigrade for 1 hour. With this process, as a rule, an excellent full white is achieved which will induce storage and is light proof. Satin tusa silk cannot however be bleached to a full white even applying the process. Optical whitening. In order to enhance the whiteness of the fabric, treatment is carried out with a optical brightening agent. The optical brightening agent may be supplied along with the bleaching agent during the process of the silk. Dyeing of the silk. Since silk is a natural polyacrylamide fiber, it can be dyed with the various classes of dyes as acid, basic, direct, reactive, metal complex and solubilized wet dyes. The pH of the dye bath and the temperature of dyeing should be adjusted in such a way that slow and even absorption of the dye takes place from the start. Printing of the silk is done mainly by hand block printing, screen printing methods. The hand block method is slow process. The different styles of printing are direct. Discharge and restyle printing, hardly any other fiber can be printed with so many different classes of the dyes. The following classes of the dyes can be used to print the silk. They are acid, metal complex, reactive dyes, white dyes and indigo dyes. This wide variety is due to the fact that a high portion of the silk in the market is always claimed by discharge printing. Finishing of the silk. Silk being a noble fiber, care must be taken during its finishing so as not to affect its classical feel, scroopy, handle and shimmering appearances. During finishing, silk is treated for following properties: crease resistance, anti-static effect, spot resistant water and oil drops and flame retardancy, dimensional stability with hand washing. Care in finishing after bleaching. Washing silk items. Gently hand wash silk items using very cold water. Apply a very mild detergent such as Woolite or Dr. Bronner's baby soap. This soap will help preserve the garment's natural oils. Rinse the item in cold water until all the soap residues has been removed. Add a few drops of hair conditioner to rinse the water to keep the silk soft and flexible. Press the water out of the fabric by rolling it in a towel. Do not twist or wring as this will damage the fabric. Hang the wet garment and allow it to air dry completely. Do not hang silk garments in the sun to dry. Iron only when absolutely necessary. Use a cool iron with a pressed cloth between the iron and the fabric. Additional tips and advice. Unless a tag on your silk fabric recommends dry cleaning, it should be avoided as dry cleaning will shrink certain types of the silk. Use lemon juice or vinegar to spot clean, but test inconspicuous area first to test for the color fastness. Be gentle, is the agitation from the washing machine causes this material to shrink. Even the gentle cycle on the washer is too rough for its delicate fiber. To keep the silk from yellowing, add half cup of vinegar to the rinsing water. Since silk is a natural fiber, do not use bleach as it will damage the fibers. Be careful not to let hairspray and perfume get on the silk as the alcohol will damage the fabric. If you have hard water, you may want to add a tablespoon of borax to the water prior to washing. Conclusion. Thus, it is concluded that silk is lustrous, precious, natural fiber, is popular for its highest composition among all fibers as the queen of fibers and requires careful processing so as not to affect its feel and appearance. It is worn as a symbol of royalty. Silk is processed well with a great care, will fetch great deals of the export earnings.